Hey folks, good morning. Again, my name is Michael Wilson. I'll be moderating today's Safety Connection ISO 10218 Insights, hosted by Mr. Rob Vomiero. A reminder again, everybody, please mute your microphones so we don't share the feedback with everybody on the call. We'll go ahead and get started now. Start off today's session again, going from 10:30 till about noon. Rob will go through how best to provide questions and answers. Rob, if I can get you to move on to the next slide, we'll go ahead and get started. Folks, on the slide right now, you'll see a QR code as well as an internet link. Okay, to better understand who's participating in our safety connections and ensure we're providing accessible training for all people in Ontario, we'd like to invite you to participate in a short survey. We are collecting demographic information on behalf of our funder. That's the Ministry of Labour, Immigration, Training and Skills Development, or MLITSD. Your responses are kept secure and anonymous, and the MLITSD will not receive any of your personal information. WSPS will be analyzing these survey results in aggregate form prior to sending them to the ministry. Of course, completing the survey or answering any of the questions is completely optional. The access to the survey is via the link. It's going to be in the chat or using the QR code on the screen. You will need to add the 6-digit function number to start the survey. Today, the function number is 230396. Thank you for taking the time to complete that survey and helping to make health and safety training accessible for all. Next slide, please, Rob. Now, before we get started with today's webinar, I'd like to review some of the webinar housekeeping items with you. Firstly, we recommend you use your computer audio with headphones, but phone conference audio is available. The phone conference audio details can be found in the access email that you received. Your camera and microphone will remain off for the remainder of the session. Next slide, please. We do appreciate your participation through the webinar. Within this meeting, you have the option to use reactions accessed in the menu bar. Reactions are instant and will float up on the screen. We will be asking some poll questions throughout the webinar as well. Those will also pop up on your screen and/or in the meeting chat. Please select your answer and select Submit to participate in the poll questions. Depending on your organization's security, you may not be able to interact with the poll questions. If you determine this is the case, please use the chat to participate in the poll questions. The meeting chat is accessed under the menu bar, and the chat is public, so everybody sees that chat. Messages can be sent in the chat at any time. We will do our best to keep up to speed on the questions as they come in. Next slide, please, Rob. Microsoft Teams offers 2 accessibility features which may be of use. To enable live captions, select More from the menu bar, Language and Speech, and then turn on Live Captions. To enable full screen mode, select View from the menu bar, More Options, and then Full Screen. Both features can be disabled by following the same instructions. If you have any technical difficulties throughout the webinar, please send a message in the meeting chat or respond using the VIA access menu that you received. Next slide, please, Rob. And the Safety Connection program has 4 main goals. Number 1, to learn, share, and discover what is of value to you, our customers, and our community. To connect virtually with industry peers, to facilitate a best practice exchange, and to provide an opportunity to attend a health and safety webinar from your personal workspace. With that, we'll go on to the next slide, and I will turn things over to Rob for the balance of today's session.
Well, thanks, Mike. Great job. Good morning, everyone. My name is Rob Vomiero, and I'm a specialized consultant with the Workplace Safety and Prevention Services. I just wanted to start out by thanking all of you for taking the time from your schedules to attend this session. A lot of work, time, and effort goes into developing these standards, regardless of the standard. And I can tell you that a ton of work went into the development of this new ISO 10218 industrial robot standard. And we're excited that this standard has been rolled out this year and to share some information about it with you. Today's agenda, we're going to cover, it's going to be broken down into 4 modules. The topics we're going to cover include just an overview on robot safety standards, development, and just a bit of an overview of that process. Module 2, which is the longest module, will highlight some changes in the new ISO 10218. Module 3, what is CSA Z434.1 and why is it important? And we'll talk about that a little bit later. And module 4, we will briefly talking about an upcoming new technical report that ISO is working on, ISO TR 2218-3, and give you a bit of information on what that's all about and how that will help you. So with regards to questions, like Mike mentioned, please type your questions into the chat. We have about 90 minutes together. I hope I can take some questions at the end, but as you can imagine, there's a lot of content to cover. We will try and take a couple of questions, hopefully, throughout the session. You know, in an effort to try and make things a little bit more interactive. But again, if we don't get to your question during this session, we will follow up with you. All the questions will be gathered, and we will be sending out a mass email with all of the questions and responses to those questions, along with additional resources. So please bear with us, and apologies in advance if I don't get to your question. But again, yeah, time is limited and there's a lot of content to cover. So thanks very much in advance. Another thing I wanted to sort of mention to everyone as we get into the first topic, robot safety standards development overview, is it never ceases to amaze me how much work goes into developing these standards and the dedication of some of the individuals that sit on these standards committee, which happen to be voluntary. So many of the individuals that develop these standards actually have other jobs. So again, there may be some committee members online. I just want to send a quick shout out to all of them because again, a lot of work does go into these standards. And as you'll see in a few minutes, I'll give you a bit of an idea of how much work went into this ISO 10218. Okay. Jessica, if I can get you to launch the first poll, we want to get a sense of how you would rate your experience with robot safety standards. So either ISO 10218 or CSA Z434, which is our Canadian industrial robot standard. And again, regardless of the version, whether it's an older version or a new version, let us know by answering the poll what your experience is with these standards. So we'll give you a couple of minutes to do that. We're starting to get some responses in. We'll give you another minute or so. And it's looking like most of you fall under category B, somewhat knowledgeable. So it looks like a lot of you on the line have some experience with robot standards, which is great. But regardless of your experience level, we're hoping there's going to be something for everyone in this session. And we encourage you to reach out to us, regardless of your level of knowledge. Hopefully, you know, there's maybe additional information that we can provide, or maybe a different perspective. I'm fortunate enough, working for WSPS, to be able to sit both on the 10218 committee and the Z434 committee. But having said that, I'm newer on these standards committees. There are some individuals that have been on them for decades. So again, if there's a question that I can't answer, there are certainly those that I can reach out to, other experts that can certainly provide you with, or provide us with the answers you're looking for. I'm hoping I can answer most of your questions, but again, I'm lucky enough to have a pretty wide network of individuals, of experts that I can reach out to. So thanks for that. Thanks for answering the poll. Most of you fall under, like I said, B. Let's go on to the next poll. So to what degree is your workplace involved with robot applications that involve collaborative tasks? And we're going to be talking about this topic quite a bit in this session. Okay. Take a minute to respond, and I'm just curious to see what your exposure to collaborative applications is. Oh, wow. Okay. Quite a few of you answered A, which means you currently have a collaborative application or applications already in operation, which is great. A few of you answered B. A larger number, or almost equal, answered C and D. So again, that's great. Collaborative applications are definitely a topic where a lot of work has gone into with respect to providing additional guidance in the new ISO 10218 parts 1 and 2, and we'll get into that. So I'm hoping whether you already have a collaborative application in operation, or you're thinking about it, or you're trying to decide whether a collaborative application is suitable for your process, I'm hoping what we talk about today is going to provide you with additional information to help you make those decisions and to be more comfortable with the technology. So again, thanks for answering that poll. Let's keep going. So we're going to talk a little bit about how standards are developed. How are they developed in Europe? How are they developed in North America? How is Canada involved with ISO? How does ISO influence CSA's robot standards? So our CSA Z434 standard. And what's different this time around? Okay, so these are some of the topics we're going to talk about in the next few slides. And hopefully this will provide some insight. So just a brief review. As many of you probably know, and there may be those that are not aware, that our current CSA industrial robot and robot system standard is Z434 2014. In the US, their standard, their national industrial robot standard is NCRA R1506. And actually, I didn't include it here, or at least in the second point, but their standard is a 2012 standard. Both Z434 and R1506 consist of two parts. Part 1 is intended for the robot manufacturer. So these are the requirements that the robot manufacturer has to adhere to, if you will, for when they design and build the off-the-shelf robot. So again, your Fanucs, your ABBs, KUKAs, Nachi, and so forth. Okay, they are going to be very interested in part 1, of course. Part 2, in the current robot standards, focuses on robot systems integration. So again, it's written for the integrator. So the integrator, if you're not aware, is the entity that takes the off-the-shelf robot and integrates it into the robot application, if you will. So both the Canadian and US robot standards, the current robot standards, are adoptions of ISO 10218 2011, if you look at the third point on the slide, which is the International Robot Standard. Just as an FYI, the R1506 2012 standard fully adopts ISO 10218 2011, whereas the CSA Z434 2014 standard also adopted ISO 10218 2011, but contains Canadian deviation. What are Canadian deviations? Canadian deviations provide additional information and user requirements for the end user. Now, why do I mention this? This is going to become important later on when we talk about what's to come with the new Z434 and R1506. So the new upcoming new Z434 Canadian and R1506 US robot standard. So who is ISO? Again, some of you may be very familiar with ISO, others maybe not so much, but ISO stands for the International Organization for Standardization. They're a nonprofit organization, as are many, or I guess most, standards development organizations. They're a worldwide federation of national standards bodies representing approximately 172 countries. And it brings together experts from all of these countries for the development of consensus standards. Why is that important? Okay. Well, the reason that's important is because ISO is made up of various technical committees. ISO TC 299, Technical Committee 299, is the technical committee that focuses on robot standardization. Working Group 3, which is one of the working groups that falls under TC 299, is specifically responsible for developing and maintaining safety standards for industrial robots. And, you know, as you probably guessed, they are the developer of the ISO 10218, Parts 1 and Parts 2. ISO TC 299 Working Group 3 consists of various mirror committees from member countries, including Canada. So again, one of the committees I'm lucky enough to be part of. Okay. So how does Canada and other countries contribute to international standards committees? Well, in Canada, we have an organization called the Standards Council of Canada, which is a federal crown corporation, and SCC oversees our national standardization system, if you will. So some of their key roles nationally, they coordinate and oversee our national standard system, but they also accredit standards development organizations, SDOs, such as, you guessed it, CSA, the Canadian Standards Association. Also, internationally, SCC is a member body of the International Organization for Standardization. They are also a member body of the IEC, which is the Electrotechnical, well, I forgot a word there. Oh no, sorry, International Electrotechnical Commission. So these are both standards, international standards development organizations. And the SCC is a member of both of those organizations. And this is how Canada contributes to international standards development through the Standards Council of Canada being a member body. Similarly, ANSI, the American National Standards Institute, is also a organization in the US that oversees the development of voluntary consensus standard, voluntary national consensus standards in the US. And similar to the Standards Council of Canada, they coordinate standards development and they accredit what are called ANSs, American National Standards Developers, such as A3, which is the Association for Advancing Automation. Some of you may know them formally as the Robotics Industries Association, the RIA. So again, they are a member of the of ISO and the IEC, and this is the way that the US contributes to national standards, international standards development, which then are adopted nationally. Okay. So I know it's a lot of information, but this kind of gives you an idea on that bridge between sort of our national standards and international standards. So back to ISO 10218, 1 and 2. The new ISO 10218 that's just been released earlier this year actually was in development for 7+ years. So why did it take so long? Well, firstly, there's a significant amount of content that's been added to the new ISO 10218. Part 1 is approximately 2 times longer, and Part 2 is actually 2.5 times longer. Some of this additional content includes the rolling in of ISO technical specifications and technical reports that are separate documents, but as part of the ISO 10218 have been rolled in and added to the annexes, with 3 documents that are on the slide. These have actually been added into the annexes of Part 2, which I will discuss a little bit more later on. ISO 10218 harmonization with the machinery directive also required additional content and additional reviews by the ISO Commission. I'm not going to go too far into this topic, but the previous ISO 10218, as well as the new ISO 10218 that was just published this year, is a harmonized standard within the EU, which following harmonized standards in the EU, I'll just say is part of the requirement for being able to apply CE markings to equipment that operate in the EU. Again, which is a requirement for this equipment to be put into operation. So it was very important for the new ISO 10218 to be a harmonized standard. So this also added time to the development cycle. And lastly, and as you can probably imagine, definitely COVID lockdowns caused numerous delays in meetings, so fewer face-to-face meetings because of lockdowns, and draft standard reviews by ISO. So all of this together really stretched out the development cycle. But after a lot of time and effort, delays, challenges, and so forth, the updated ISO 10218 2025, parts 1 and 2, and yes, they are published separately on the ISO site. They were published in February of this year, February 2025. So, and that was exciting news because we had been waiting for the development of this new standard, for the publishing of this new standard for quite a long time. So now that the new ISO 10218 1 and 2 have been published, what's next? Well, CSA Z434 and A3R1506 committees, which are the Canadian and US national committees that develop the Z434 and R1506, are working to adopt the new ISO 10218 Part 1 and Part 2 for Canada and the US. So this is currently in progress. Okay, so yes, we will have a new industrial robot standard in Canada and in the US in the near future. What are the timelines that we anticipate? The US plans, and again, this can change, but the US plans to adopt and publish the new A3 R1506 Part 1 and 2, and a new Part 3, which we'll talk about in a second, by the end of 2025. Now, please keep in mind that can change. And the Canadian plan is to adopt and publish the new CSA Z434 Part 1, 2, and the new Z434.1 sometime in the first quarter of 2026. And a big change in the new Z434 will be that it will not contain any Canadian deviations. So the question you may have in your mind is why? Where are the deviations going? And that takes me back to the second point on this slide. Canada and the US are also working on an additional standard or an additional part for North America called in Canada Z434.1, and the US it'll be simply called Part 3, which will be titled Use of Industrial Robot Standard. So what is the purpose of this Z434.1 or Part 3, or what will be the purpose of it? It will be to provide requirements and guidance to the end user, which again, here in North America is very important. And I'll talk about this a little bit more in the coming slides. So the last slide I wanted to share with you, I just wanted to give you a visual in this graphic of sort of the development history of the evolution of the US, so the ANSI RIA, which is now going to be, or will now be known as ANSI A3, so the development of their robot standard, the development history of the ISO 10218 standard, and the development history of the Z434 standard. For those of you that do have experience with robot standards, you're probably aware that the ANSI RIA R1506 1999 was a pivotal standard. And it really, I call it like a launching pad for all of the subsequent standards that came along, both in the US and Canada, but with respect to ISO as well, which the arrows are supposed to sort of signify. So again, this is just a quick visual for you, but this gives you an idea on what the history and the evolution of the robot standards was. Okay. So Mike, I'm going to take a pause for a second. Are there any questions from anyone in the chat? I can't really see the chat really well.
Don't see anything in the chat right now, Rob,
Okay.
so I think you're okay to keep going.
Okay, great. Thank you. So again, that's a little bit on standards development and kind of how things work. Let's get into module 2 of our session, which is, I guess I would call the nuts and bolts of this session. Let's highlight some of the changes in the new ISO 10218. Okay. So the first thing I want to mention, sort of clear up and make sure everyone is aware of, is that a risk assessment is still a requirement in both Part 1 and Part 2 of the new ISO 10218. However, the new ISO 10218 has also introduced a number of prescribed requirements relating to functional safety requirements. So for those of you not familiar with the term functional safety or performance requirements, really that speaks to the reliability of safety functions and the safety functionality of robotic applications. Also, I wanted to highlight, just to get us going, that Part 2, Annex C, you don't have to worry too much about remembering these annexes, but Part 2, Annex C has introduced some robot-specific risk assessment analysis criteria, which kind of got cut off in my slide. But basically, when you get a chance to look at Part 2, Annex C, you will see that risk assessment criteria that is robotic specific has been added for the analysis of risk. Okay, so to implement into your risk assessment processes. So that's key. So if we dig a little bit deeper into the change highlights or the changes into the ISO 10218, and these are really, these span across both Parts 1 and Parts 2. There are additional requirements for design, which we really don't have time to get into in this session, but I just jotted down one example, which is robot position holding requirements without power. So yes, there is additional guidance that has been added into the robot standard. In particular, if that position holding is accomplished using safety functions. So there is additional guidance provided in the new ISO 10218, and because in this case we're talking about the robot itself, this is specifically in Part 1, there is additional guidance provided on the design of the robot, okay, which is going to be obviously of interest to the robot manufacturers out there. Mode requirements, so automatic and manual mode for your robot and your robot applications. Again, not a topic that we can really dig into and that we have time to dig into in this session, but that is another change that you will see in the new ISO 10218. The third point is actually very significant, and we'll spend some time on this. And what we're talking about there is the clarification of requirements for functional safety. The fourth point we will also spend some time on because it is a significant change. The introduction of robot classes in part 1. So class 1 and class 2 robots and their related functional safety requirements. So some additional change highlights. Test methodology to determine the maximum force per manipulator, or for the robot arm, for class 1 robots. And we'll talk a little bit more about that in the next few slides. As you can imagine, there are added requirements for cybersecurity in both parts 1 and parts 2. There's the third point, incorporating safety requirements for industrial robots intended for use in collaborative applications. We will spend some time on this point in today's session because this is a significant change. There has been a lot of guidance added into both part 1 and part 2 of the new ISO 10218 on collaborative applications. And then, like I mentioned a minute ago, the addition of risk assessment protocols, so risk analysis criteria specifically, has been added in part 2, which are focused specifically on robotic applications, which are going to have an impact on how risk assessments are carried out. So let's talk a little bit about functional safety requirements. And remember, when I say robot functional safety or performance requirements, again, if these are terms you're not familiar with, really we're talking about the level of reliability of the safety functions for a robot application that ultimately are keeping workers safe. So in the previous version of ISO 10218, which would be the 2011 version, the requirement was that the safety-related parts of the control system, which is what that acronym stands for, SRPCS, required a minimum performance of PLD Cat 3. Okay, so that is that is if you will, a safety reliability rating for the safety functions that make up a robotic application. To dig into that a little bit more, what the previous version of ISO 10218 told us was that the protective stop function needed to meet, again, a minimum performance requirement of PLD Cat 3 or SIL 2 with a hardware fault tolerance of 1. Don't worry too much about the terminology. Again, we're talking about safety reliability. And the emergency stop function. And these are both stop functions that were required and are still required in the previous version of ISO 10218 and the updated version of ISO 10218. The minimum performance requirement was also PLD Cat 3 or SIL 2 with a hardware fault tolerance of 1. All right. What the previous version of ISO 10218 also told us is that a risk assessment could determine alternate performance requirements. So it was felt that there was a lack of clarity on performance requirements for specific robot safety functions in the previous version of ISO 10218. Now, since ISO 10218 is a Type C standard, which means it's an equipment-specific standard, it was felt by the technical committee and as well as in the effort for the new ISO 10218 to be a harmonized standard, that increased clarity was needed on performance requirements for specific robot safety functions. Okay, so in other words, the performance requirements for robot safety functions have become more prescribed in the new ISO 10218, in particular in part 1, but to a certain extent in part 2 as well. And we'll dig into that a little bit more. So let's talk a little bit about robot classes. The new ISO 10218 Part 1 has introduced robot classes, Class 1 and Class 2. So you can see the criteria or the performance criteria for each of the classes on the slide. Now robot manufacturers following the new ISO 10218 will be classifying robots as class 1 or class 2. Now for class 1 robots, the above criteria, the listed criteria, and this is important to note, it shall be the maximum capability of the manipulator without any limiting safety function. So what does that mean? That means that in order for a robot to be classified as a class 1, one of the criteria it needs to meet is that none of those characteristics listed under the class 1 robot are exceeded. Those are the worst case scenario performance criteria for the robot without being limited by safety functions. When I say safety functions, those are functions such as safety rated monitored speed, monitored standstill for position monitoring, and so forth. So again, those values, those performance criteria are listed under class 1 have to be the worst case scenario performance criteria that the class 1 robot or that the robot can achieve in order to be deemed class 1. So another important note with respect to class 1 robots is that the robot has to meet all 3 criteria that are listed. If it doesn't meet all 3 criteria, it will be classified as class 2. So 2 out of 3 isn't enough. It's got to be all 3 criteria have to be met. And then the last point I want to make is that testing must be carried out in order to classify the robot as class 1. And there is testing guidance provided in class 1 under Annex E. We'll have to remember the annex, of course, but the important note is that there is testing guidance provided in the annex of Part 1 for the robot manufacturer in order to classify it as a class 1 robot. Okay. Now, because class 1 robots have reduced performance capabilities and characteristics, so reduced mass, reduced speed capability, and reduced force output, as you saw in the previous slide, there is a lower functional safety performance requirement for the safety functions related to the class 1 robot. And the minimum requirement in the new ISO 10218 Part 1 is a performance level B or SIL 1. Another interesting note about class 1 robots, if they've been classified as such, they are not required to have a 3-position enabling device, which is the control that some of you may be familiar with, that you usually find on the back of the teach pendant that enables the robot to be operated in manual mode. Now, the 3-position enabling device is not required on a class 1 robot if foreseeable robot tasks can be performed safely without an enabling device. So this will be risk assessment determined, I guess, or they will, not I guess, they will be. But it is also important to note that the robot manufacturer must provide safety inputs for the integration of an external 3-position enabling device if needed. So the safety inputs have to be there, but depending on the risk, an enabling device may not necessarily be required. And so again, any robot for which testing is not conducted to validate class 1, in particular the force output of the manipulator, will be classified as class 2. Some robot manufacturers may have smaller robots, which may or may not fall under the requirements of class 1. They may decide not to do the testing that's required. So those would be deemed class 2. Okay, so I'll just take a quick pause. Mike, anything in the chat with regards to questions?
No questions that haven't been already addressed. So I think you're
Okay.
good to continue, Rob.
Good, thank you. I know it's a lot of information, everyone, but yeah, these are, again, are all important changes. I'm going to talk a little bit about the class 2 robot, which, as you can imagine, looking at those criteria that I showed you for both class 1 and class 2 earlier, most of the robots on the market will be class 2 robots. The minimum functional safety performance requirement for class 2 robots is there's different options. It can either be a performance level D category 3 per ISO 13849-1 or SIL 2 with a hardware fault tolerance of 1. I didn't include it, but that would be per the IEC 62061 functional safety standard. Or the third point is a new criteria that the committee has added, which is either a performance level D or a SIL 2 performance with a PFH of less than or equal to 4.43 times 10 to the negative 7 per hour. What does PFH stand for? It is a function. It is a term that you will find in functional safety standards that stands for probability of dangerous failures per hour. And you can see that the number is very, very small. Even not knowing anything about functional safety, which there's probably people on the call that are very comfortable with functional safety. It might be newer to others, but you can see that the value is very, very small. 4.43 times 10 to the negative 7 dangerous failures per hour. So it's a very, very small value. So what does this tell us? This tells us that a category 3 or a redundant architecture for our safety systems, sometimes referred to dual channel, is not required if your safety function, and really a robot application is made up of a series of safety functions, can achieve a probability of dangerous failures of the 4.43 times 10 to the negative 7 per hour. Now, we're not going to dive into or dig into what that actually means. For the purposes of this session, I would have to point you to ISO 13849-1 or IEC 62061 for more information on the definition and what probability of dangerous failures per hour are. But again, we're always talking about the reliability of the safety functions. And the reason this was added, this third criteria, is that although it is difficult to achieve that probability of dangerous failures per hour with a single channel architecture, with newer technologies and various electronic safeguarding devices and components making up the safety functions, it can be achieved. So again, it was to provide greater flexibility to achieve a very reliable safety function without necessarily having to have a redundant architecture. Although most of the safety function architectures will likely continue to be category 3, which again means dual channel redundancy, there is this additional option of trying to achieve the probability of dangerous failures per hour. Another important element of part 1 that I want to bring everyone's attention to is that there's no provision allowed to use a risk assessment to justify a lower performance requirement than specified above, which are your minimum performance requirements for class 2 robots, or in Annex C. And we'll take a closer look at Annex C in the next slide. So that's a lot. That's a lot to digest. I get it. It does get a bit on the technical side. Again, Mike, any questions? I just want to make sure.
Yep, Rob, we did actually have one question here. Okay. Is the classification part of robotic specifications when purchased, or is this something that we would need to complete at the industry level based on integration?
Okay, so how it actually happens with different robot manufacturers, I'm not sure about how they're going to actually execute on that, but it is a part 1 requirement. So the classification will happen on the part of the robot manufacturer, not the end user. I hope that answers the question. Let me know, Mike, if there's any follow-up.
Yep, I've got a thumbs up here. Absolutely. Thank you.
Okay. So a little bit more on functional safety for class 2 robots. I mentioned Annex C. Why is Annex C important? Part 1, Annex C, has 2 tables in it. Table C1 and Table C2. Table C1 lists robot safety functions that must meet the minimum performance requirement that we just talked about. So the PLD or SIL2, again, with either category 3 or the PFH requirements. All of those functions that must meet that requirement are listed in Table C1, which I didn't include here. But again, you'd have to look at the standard. But a couple of examples would be interlocking function, the protective stop function, mode activation safety function. So these are examples of some of the safety functions that have to meet that PLD or SIL2. However, Part 1 also has a second table, C2, which provides alternate minimum functional safety performance possibilities for specific safety functions. Things like the emergency stop, which if you look at table C2, it'll say that the minimum requirement is a PLC SIL1. The normal stop, which the minimum requirement is a PLV, and we'll talk about what a normal stop is in a few minutes, and the reset function. There are others, I just listed a few examples. So Annex C is very important because, again, it contains these two tables, and it really gives you a more prescribed guidance on what the actual performance requirement or reliability of these robot safety functions need to be. Again, in the previous ISO 10218, if you recall the earlier slide, it was a lot more broad. It basically said that the emergency stop function had to be PLD, minimum PLD Cat 3, and the emergency stop function and the protective stop function had to be a minimum PLD Cat 3. But it didn't really dig into other specific robot safety functions. So when I say that the new ISO 10218 provides more prescribed guidance on the reliability of safety functions, this is what I'm talking about. The information that's in Annex C in these two tables. And just doing a quick time check. So now we've been talking about Part 1 with respect to functional safety requirements. What about Part 2? So functional safety performance requirements for the robot application. So again, similar to Part 1, the safety related parts of the control system, which is an ISO 13849 acronym, or the safety control system, which is an IEC 6261 acronym, but it talks about the safety functionality of the overall application as opposed to just the robot. Part 2 outlines two approaches for the integrator to determine the performance of each required safety function. Again, there's an Annex C in Part 2. You can either follow the required performance level or SIL levels listed in Annex C, Table C1 of Part 2. So again, similar to Part 1, there's an Annex C in Part 2, which lists minimum requirements for performance. However, there is a second option for the application where the performance requirement can be determined based on the results of a comprehensive risk assessment. So again, the risk assessment remains very important for the overall application. There is more prescribed guidance provided for the minimum requirements on a per application safety function basis, as opposed to providing the broader guidance that was in the 2011 version. But again, the risk assessment process can also be incorporated here for the overall application. And so again, I know this is a lot to digest, but it is a big topic in the new ISO 10218. Now again, similar to Part 1, in Part 2 for the overall robot application or robot cell, if you will, where PLD or SIL2 safety performance is required, the actual structure of the safety function remains the same as part 1. So either you're going to have a category 3 architecture or a hardware fault tolerance of 1, or you need to meet the probability of dangerous failures per hour criteria listed. And it stands to reason that obviously, since the robots are being integrated into cells, that those requirements would align between part 1 and part 2. Okay. So that's a tough topic. We're going to move off, at least for now, functional safety requirements. Well, we never really move off the topic, but we're going to focus a little bit in the next couple of slides on stop functions. So what's changed? In the previous version of ISO 10218 1 and 2, again, the 2011 version, robots and robot systems were required to have, I mentioned this earlier, an emergency stop function, which is a function intended to avert or reduce existing hazards, a protective stop function, which is a function intended to stop the machine in response to a safety-related event. So typically we would say that obviously emergency stops would be integrated into the emergency stop inputs, and your safety devices would be integrated into the protective stop inputs of your robot system, okay? But what's changed for ISO 10218 2025? Well, there's an additional stop that's been added. There is now a requirement to have something called a normal stop function for both the robot and the robot application. And what is a normal stop? Well, it's just another type of stop. The definition of it is a function intended to stop a machine as part of a routine operation. So for example, stopping a machine, a line, a process at the end of a shift. So again, there is now a requirement to have this normal stop function. Why was the normal stop function added? Well, one of the main reasons, again, was to achieve harmonization with the European Union Machinery Directive. That was, again, like I mentioned, it was a key goal of TC 299 Working Group 3. And in order to achieve that harmonization, that normal stop needed to be added to the standard. Because the normal stop function is intended as a routine operation, it has a lower performance requirement, a minimum requirement of a performance level B. Just pause there for a minute. Mike, any questions about functions?
Not about stop functions, Rob, but we do have one question is, would we need to update the robot systems if you reuse or redeploy older class 2 robots and add them into a new cell? That's a good question.
Yeah, and that's a rabbit hole right there. as I'm sure the attendee can imagine. So all right. So the answer to that question is longer-winded. So I encourage you to either reach out, but the short answer is from a standard standpoint, if the robotic application, if the robot and the robotic application met the standard or was compliant with the standard in effect at the time that the cell was built, the robot and the cell were built, then no, you do not need to update to the latest standard. But there is a caveat. We need to make sure that whether it's robotic systems, machinery, whatever the case might be, that they meet the minimum requirements of the legislation for the jurisdiction that they're being operated in. So, so just keep that in mind. I know that's a high-level answer. That may not answer the question fully, but again, I always like to make sure that when I'm training, that compliance with the law comes first. Those are your minimum requirements, and then of course, we use the standards to give us the details on how to achieve compliance with the law. And of course, if your existing robotic applications were compliant whether you're in Ontario and you had a pre-start health and safety review done and there were no outstanding issues, or whatever the case might be. But if your equipment was compliant with the standard in effect at the time it was built and installed, no, you don't need to run out and update all of your equipment, as long as there's no aspects of it that are out of compliance with legislation. So I hope that kind of answers the question, but we will gather all these questions and maybe send out more detailed responses to them. And
That's
also,
great, Rob.
yeah, and I was going to say also, feel free to reach out to me.
Yeah, we do have one other question related to
Okay.
e-stops in the chat here. If the emergency stop is performance level E as in Everest, but the protective stop is PLD as in Delta, what would we call this robot, a PLE or a PLD?
Well, okay, so you know what, read it one more time. So the protective stop only meets a PLD, but the e-stop is capable of a PLE. Is that the question?
That's what I'm getting from the question here in the chat, yes.
So really, in general terms, when it comes to functional safety and safety functions, generally speaking, the weakest link in the chain. So when I say the chain, I mean the components that make up the safety function. So in this case, the e-stop would be the input device. You may have some logic element and output devices. You would likely end up with the lower performance requirement. So likely the PLD. Now, I'm thinking this is just an example. Very difficult to achieve a PLE with an e-stop, a PLE performance. But again, I'm not sure if this is an example or an actual, like if this is an actual situation. But generally speaking, in my knowledge of, and again, there are others out there that are much more knowledgeable on functional safety, the weakest link, so the PLD would probably take precedence. And then we'd have to look at the other components that make up the safety function. So I hope that kind of answers the question.
Yeah, I think something like that would require a more detailed analysis based on a review of the complete system. So yeah, I think you got it there, Rob.
Yeah, thanks, Mike. Not a lot of information in this session on cybersecurity. However, it is an important element that has been added to both parts 1 and 2 of the new ISO 10218. There is a requirement both on the part of the off-the-shelf robot and the application or the cell that a cybersecurity threat assessment be conducted. And then resulting from that, or the outcome of that, should result in cybersecurity measures for threats related to safety risks. So think about systems that are operating over a network and risks related to hacking and taking control of equipment and so forth. So again, cybersecurity measures for these types of threats would need to be put in place. So of course, some of the things that the standard points to is preventing unauthorized access to the robot control system, plus its hardware, software, application software, and related configuration data. So pretty broad. The standard doesn't provide a ton of information on this, but it does point us to 2 important standards. The IEC Technical Spec TS 63074-2023 for functional safety requirements related to security, network, and cybersecurity measures. As well as the security risk assessment for system design, IEC 62443-3-2-2020. So for those of you that are involved, IT departments and so forth, that are going to be involved in setting up things like firewalls and other cybersecurity measures, these are 2 important international standards that the new ISO 10218 points us to. Okay, so let's move on to collaborative capabilities and tasks and applications. You notice I'm not saying collaborative robots or cobots anymore. One big change in the new ISO 10218 is that there is no term defined for collaborative robot, or the shortened term that we've coined, often referred to as cobots. Now, I know these terms will continue to be used, and it's going to be a bit of a paradigm shift over time, but really, we want people to start thinking in terms of collaborative applications, collaborative capabilities, and collaborative tasks. There are no collaborative robots in actuality. Actually, what we're talking about is industrial robots that have that come equipped with certain safety functions that allow interactions with humans, and that's what collaboration and collaborative tasks are all about. They're tasks where the robot and the human can be within the same safeguarded space at the same time, and they can interact to varying degrees depending on the safety functions and the manner in which the system has been set up. So we're going to talk about that a little bit more in the next couple of slides. So what is a collaborative task? It is a portion of the robot sequence where both the robot application and the operator are within the safeguarded space. All right, so that's just a definition. And it's a term that you're going to hear used more and more in relation to, as a result of the new ISO 10218. And what about a collaborative application? Collaborative applications are simply robot applications that contain one or more collaborative tasks. And for those of you that will be using the standard, you're going to quickly see, and I talk a little bit about it in the next couple of slides, that you can have robot applications that have both collaborative and non-collaborative tasks. They're hybrid. And the transition between those different areas of the robot cell becomes very important. I'll talk a little bit more about that in the next couple of minutes. So let's continue to talk about collaborative capabilities. Collaborative tasks and applications are performed by industrial robots with specific capabilities, which consist of specific safety functions. These collaborative capabilities, as I'm referring to it in this session, are, and some of you are going to be familiar with some of these terms from the previous standard, hand-guided control, speed and separation monitoring, and power and force limiting, right? And those are the acronyms that you see beside those terms, which you will, which you have and you will continue to commonly see. Now, for those of you that are more familiar with the previous version of ISO 10218 and our CSA Z434 standard, there was another what was referred to as type of collaboration that was listed, which is really a misnomer now. We used to also list safety rated monitored stop as a type of collaborative operation. Well, you're going to notice in the new ISO 10218 in both parts 1 and part 2 that safety rated monitored stop is no longer listed as a collaborative capability, or as a collaborative or a safety function that allows collaborative applications. Okay, so, and the reason for that, takes us to the next slide, is that safety rated monitored stop, first of all, is now referred to in the new standard as monitored standstill, and it's no longer listed separately as a type, and using air quotes here, as a type of collaborative operation, because it is actually integrated into the other 3 types. So monitored standstill is one of the safety functions that is implemented into hand-guided control, speed and separation monitoring, and power and force limiting. So it's no longer called out as a separate type of collaborative operation, but it does still exist, and it is still incorporated into the other collaborative capabilities. Okay. You'll find this information in part 1 of clause 510 of the new ISO 10218 standard. So let's talk a little bit more about collaborative applications. So part two provides guidance on risk reduction considerations for the overall collaborative application or the robot itself, not just the robot like part one does. So the risk assessment is key. So I mentioned right at the beginning that risk assessments are still required for the robot and the robot application. Well, the risk assessment is key for collaborative applications to determine measures to prevent what we refer to as quasi-static contact events, which are crushing hazards, and transient contact events, which are impact hazards. So again, it becomes very important, and we're going to talk a little bit more about that. One thing we really need to look at is contact exposure to sensitive body regions, including the skull, forehead, larynx, eyes, ears, or face, needs to be avoided. And if risk reduction cannot be practically achieved, then yes, you may have to add guards or protective devices to your collaborative application. And we need to be very careful because, and I'm going to come back to this, but in some cases, not with, not always, but in some cases, I know what we're seeing, what WSPS is seeing when we go out to workplaces, is that there's a misconception that because a robot is deemed collaborative or sold as a collaborative robot, there's a misconception that the application can have reduced safeguards, or in some cases, what we're seeing is no safeguards implemented whatsoever. Now, this may be possible, but it is very important that the application be implemented and set up properly, and that we achieve the appropriate risk reduction in order to achieve that. And what we often, unfortunately, end up seeing is applications that the employer or the workplace hoped would be collaborative and wouldn't require safeguards, actually do require safeguards, like a traditional robot cell, in order to reduce risk. So unfortunately, I can't dive too deeply into that here, but this is something that we're seeing with the implementation of collaborative applications or robots capable of collaborative applications in workplaces. So please be aware of that. Reach out to your PSR providers, reach out to us, whoever, to get more information to make sure that we're achieving appropriate risk reduction with our collaborative applications. So some things just to keep in mind that part two is advising and providing guidance on. I mentioned that the safeguarded space can consist of both collaborative and non-collaborative tasks. Transitions, so those transition points between collaborative tasks using different collaborative capabilities like hand-guided control, speed and separation monitoring, and power and force limiting, which we took a brief look at a minute ago, or combinations of these collaborative capabilities, because yes, you can have applications that combine these collaborative capabilities. These transition areas become particularly critical. Some of the things that the risk assessment should be considering and looking for when developing their risk reduction or safeguarding strategy include the following. So making sure appropriate safeguards and safety functions are implemented to maintain separation between non-collaborative and collaborative task areas. So what am I saying here? You could have a robot cell which has a safeguarded space, and within that safeguarded space, you could have areas where it acts as a traditional robot cell, where you need to have complete separation between the human and the hazards. But you could also have collaborative task areas where the human can interact with the robot. You're going to have transition zones or transition areas from collaborative to non-collaborative task areas. and these need to be appropriately safeguarded to maintain the appropriate separation. What else? Floor markings within the safeguarded space to define areas where operators can interact directly with the robot. We need to make that very clear. Visual indicators to identify transitions between collaborative and non-collaborative tasks. And very importantly, start and restart of non-collaborative tasks. So think of those as our traditional tasks. Requires the operator, must require the operator to completely leave the safeguarded space, again, to restart the application. So again, these are just some of the points, and I know it gets a little bit detailed, but these are some of the considerations that Part 2 is asking us to consider when we're carrying out our risk assessments for collaborative applications. All right. Well, Mike, I'll take a quick pause again because I've been yakking a lot.
All good information.
Questions?
No new questions in the chat right now, Rob.
Okay. Good stuff. So some additional changes in Part 2 of the new ISO 10218 is really excellent guidance. The addition of Annex M, which provides biomechanical force and pressure limits for different regions of the body. So again, for those power and force limiting collaborative applications where the human and the robot, where there are what we call contact events, where the human and the robot can come into contact with each other, there is guidance provided in Annex M on those force and pressure limits that need to be maintained in order for the application to remain low risk. And I just want to point out, just on the side, I know we've talked about these even with respect to the previous robot standard, even though it was a separate document. It used to be an ISO technical spec. It still exists. ISO TS 15066 is a technical specification which you can obtain separately. But the nice thing about Annex M is it pulls that information into the robot standard, and what those limits are based on testing on different regions of the body that result in the onset of pain. And so these values are actually tested. So we're not talking about injury. We're not even talking about any bruising or any kind of other hazard or damage to the soft tissue. We're talking about very low forces and pressures that need to be maintained in order for the application, if it's a PFL application, to remain at low risk. Okay, so this is very useful information, because another thing that we're seeing when we go into workplaces, again, where collaborative applications have been implemented, is that we're sometimes seeing that the output forces and pressures are still quite high, and some of these applications are not guarded. But again, the whole misnomer about it being, well, it's a collaborative robot, we shouldn't need guarding. Well, I mean, have we set up the safety functions so that those forces and pressures meet the requirements of what's provided in Annex M? So this is key information that's in the new ISO 10218. Another requirement that you will find in Clause 6, again, just an FYI, Clause 6 of Part 2 of the standard is called the Verification and Validation Clause. And there is a requirement in ISO 10218 Part 2 that collaborative applications, and in particular the force and pressure outputs for PFL collaborative applications, not only be set up properly, but they need to be tested. So whether it's your integrator doing that testing, if they provide that service, or your PSR provider, if you're stating compliance to Part 2 of the new ISO 10218, which we know will eventually become our new Z434, it's not enough just to set the system up for those those low output forces and pressures. They need to be tested. They need to be validated. Okay. And then another annex that's been provided in ISO 10218 are different methods for validating PFL applications. So the methodologies are not mandatory, so we call that an informative annex, but it does provide good guidance on how the validation of those output forces and pressures can be validated. Annex N does provide that guidance. So again, another key annex that's been added to Part 2.
Hey, Rob, a couple of quick questions for you before you leave that slide. Sure. First one is, are there any changes to the biomechanical force and pressure limit values in the new standard? Are they exactly the same as TS 15066? And I'll let you handle that one before I hit you with the next one.
Okay, so so even though we have this new ISO 10218, there's still a lot of work happening on the part of Working Group 3. There is no change to those limits from TS 15066 and the rolling in of that into ISO 10218 Part 2. But I can tell you that new studies and limits are currently being worked on. And we, I don't have a timeline for you, but I know that Working Group 3 will in the future be putting out both new versions of ISO 10218 15066 and potentially updated versions of this new robot standard that will provide new force and pressure limits based on new studies. So again, continuous improvement is still happening with these standards, but really those ISO TS 15066 values those tables, table A1 and A2 in the annex, again, those are the ones that have, for the most part, have been rolled into Part 2.
Great, thanks, Rob. I think you've partially answered the next question. Has further testing in Annex M, so from TS 15066, been conducted? Participants noted that the fine print in 15066 noted it was actually a very small sample size of 100 tests total.
Yeah, it is a small sample size, that's right. I don't know the specifics of the testing that's occurring right now. One thing I know that is being worked on is both methodologies for future guidance and future standards, methodology for both testing, but as well as for modeling. So using computer modeling to validate force and pressure outputs. But I have no details, unfortunately, on what the sample sizes are for any new testing that happen or new values that are being worked on. But I definitely know that new values and improved biomechanical limit documents are definitely being worked on. When we'll see those, I don't know, it could be a couple of years, I'm not sure. But again, that is in the works.
Great, thanks, Rob.
Okay. So again, just to recap, I've mentioned this already. I won't, I'm not going to sort of beleaguer it, but again, just be careful. There's a lot of misconceptions in the field about collaborative applications. One, the misconception that a collaborative robot is inherently safe. The answer to that is no. It's not. It is not inherently safe. It needs to be implemented and correctly set up, including appropriate validation to make sure, especially for power and force limiting applications where there's contact, to make sure that those contact events remain low risk. And number two, as a result of number one, we're seeing a number of collaborative applications with insufficient or inappropriate safeguarding, which again becomes a problem because now we put ourselves in a situation where we're not compliant even with the minimum requirements of legislation. So again, you need to be, without again beleaguering it, just be prepared when enforcement officers come into your workplaces. They may be asking you these questions because again, they enforce legislation. So please keep in mind that just because you're Using a collaborative robot, it doesn't necessarily mean it's safe or that it's it's been set up with the appropriate risk reduction in mind. So please keep that in mind. And we do have that significant additional guidance in the new ISO 10218, which will eventually be our NEET 434, for making sure our collaborative applications are safe or really expose workers to minimal risks. Okay. So in terms of updates with respect to ISO 10218, that's pretty much all I had. What I just wanted to give everyone a quick visual of, or in case you don't have the standard or haven't gotten eyes on it yet, is some of the annexes that have been, some are already existing, some of them are new, but the significant list of annexes that now exist at the end of part 2. And again, these are key. They provide a wealth of additional guidance. So I really encourage you. Sometimes annexes can be an afterthought. In some cases, definitely with this standard, you shouldn't think of them that way. They really provide a lot of important guidance with respect to the implementation of part 2. And actually, for that matter, part 1. I haven't listed the part 1 annexes, just in the interest of length, but there's certainly more annexes in part 2, which is part of the reason why it's so much longer. I will bring your attention on this slide to a couple of the technical reports and technical specifications that have been rolled in to the new part 2, or the updated part 2 of ISO 10218. Some of you may be familiar with ISO TR 2218-1, which was a technical report that Working Group 3 developed after the 2011 version of ISO 10218 was published, which focused on and provided additional guidance on end effector design. In particular, or including end effectors that are being used on robots capable of collaborative tasks. Because oftentimes, for lack of better terminology, the end effector can put our collaborative application out of compliance if it poses significant risks. So think about sharp edges, knife edges, puncture hazards, and so forth. So again, can't really get into it. I wish I could we'll discuss it further. But all I'll say is that the design of the end effector with respect to making sure the overall robot system and robot application meet the appropriate risk reduction requirements is key. I've seen a number of applications where, again, the intent was to implement a collaborative application using robots capable or equipped with collaborative safety functions, and the end effector ends up causing, if you will, invalidating the application as collaborative because of the risks related to the end effector itself. So please keep the end effector design in mind. It's critical. Manual unload and load stations, ISO TR 2218-2, which is now Annex J. So that is another technical report that has been rolled in, which focuses on and provides additional design guidance for manual load and load stations related to robot applications. So again, it used to be a separate technical report, a separate document, and now got rolled into the standard. And we already mentioned ISO TS 15066. How are we doing for time? Yeah, we're getting near the end. Okay. That was the bulk of the presentation. There's a couple of other topics I'd like to cover fairly expediently. The first one under module 3 is what is part 3, which I already kind of mentioned, and CSA Z434.1, and why is it important? So in addition to adopting parts 1 and part 2 of the new ISO 10218 as our national robot standard in both Canada and the US, respectively, Canada and the US worked on and are working on a Part 3 / CSA Z434.1. Why? Well, first of all, what is it? I mentioned earlier, CSA Z434.1 will provide end user responsibilities. Title of Part 3 or Z434.1 is Safety Requirements, Use of Industrial Robot Cells. Why do we need that in North America? Simply put, we know that in certainly Canadian jurisdictions, but also in the US, the greatest responsibility for the health and safety of workers falls to the employer or to the end user. And ISO standards do not provide guidance to the end user, only to manufacturers and integrators, Part 1 and Part 2. So the CSA Z434 committee and the A3 R1506 committee felt it was important to have a Part 3 or Z434.1. In the case of Z434.1, that's where the deviations went. That's, I mentioned that earlier. This is the reason why we've been able to forego deviations in this next version of the standard. Again, part of that is because we're going to have this new CSA Z434.1. So again, I talked about timelines a bit earlier. The end of this year for the US and first quarter of next year for publishing, hopefully for Canada. But again, Part 3, as well as CSA Z434.1 will be bundled with the new Part 1 and Part 2 of our respective standards in the US and Canada. So all three of these standards will be bundled together, okay? What will Z434.1 cover? Just some quick topics without getting into too much detail. Design considerations for collaborative and non-collaborative applications. Interaction with integrators. User guidance on preparing a statement of work, right? With which both committees felt this could be very helpful, especially for those with less experience with robotic applications. Robotic application acceptance guidance. What are some of the things the end user should be considering before they accept a new application or robot cell into their facility? Implementation of the information for use by the integrator. So user risk reduction responsibilities and guidance on how to implement what we refer to as the information for use of the application or the cell, which the integrator and the robot manufacturer, for that matter, are required to provide. So again, how does that get implemented? Well, there's guidance provided on that in the new 434.1. Training requirements, which is key, especially when it comes to collaborative applications. So user training guidance and requirements. Risk assessment. What are the user responsibilities with respect to risk assessments? Risk assessment support by the end user for the integrator. Risk assessment documentation. The risk assessment process. What does the end user need to know? And guidance on methodologies for performing risk assessments. Maintaining acceptable risk. What is the user's responsibility to maintain the robot application in the state it was received in, or to do any necessary upgrades if they find the existing risk reduction measures are not appropriate? So again, that becomes very important because again, ultimately it is the end user's responsibility. I mean, it's really a shared responsibility, but once the end user receives it, they become responsible for making sure their workers are safe, right? And keep in mind, something to really keep in mind when it comes to machine safety, robot safety, and so forth, the implementation of a change management system, the very final point. There is guidance in Part 3 that talks about the implementation of a change management system, which becomes very important for maintaining our robot system. Okay, I'm almost at the end of my time. I just want to show you one more thing. Working Group 3 is also working on another document. It's ISO TR 2218-3. This is a technical report that that Working Group 3 felt would be helpful and is helpful to help integrators actually better understand and implement the requirements of Part 2. Because there's so much new content in Part 2 of the new ISO 10218, this new technical report, 2218 Part 3, again, different from the Part 3 and Z434.1 that's being developed here in Canada. This is an ISO document that is intended to help the integrator implement the requirements of Part 2 because of how much new content there is. So please stay tuned for that. It's in the draft stage and will be released in due time, and it will be a very useful document. So just again, keep in mind this recap here. I'm not going to go through them in the interest of time, but these are some of the key points we covered: functional safety and clarity on specific performance requirements, stop functions and the addition of the normal stop, more guidance provided for collaborative applications, cybersecurity requirements, and more rigorous and specific risk assessment criteria. Please keep in mind, a bit of a plug for WSPS, some of the free services that we provide, depending on your situation and eligibility, these are some of the free services that you may be able to receive. And just a quick list of some of the services that are machine and robot safety practice at WSPS, which I'm part of, some of the training and consulting services and resources, free resources that we provide. So I encourage you to go to WSPS.ca because we do have a lot of free resources that can help you in the area of machine and robot safety, as well as other areas of health and safety as well, like hygiene, ergonomics, and so forth. So please visit WSPS.ca when you can. Okay, and that's pretty much it. And I know I took a few questions and I'm about a minute over. And I imagine people are going to start to drop off. Mike, was there any other significant questions?
You know what, Rob? We don't have anything in the chat just yet, but we do have quite a few thumbs up and a virtual applause coming. Notes an excellent summary, great overview. Thanks for your time. Great presentation. I would have to agree. Again, recognizing the time, folks, thank you for attending our session today. Rob, great session, great information, and we'll stay on if there's any more questions.
Yeah, I'll hang out for a bit. Thank you everyone again for attending. I really appreciate it. Sorry for all the yakking. I know it's a lot of information, but I hope you were able to take away some good nuggets of information. Yeah. Take care, everyone. Thank you.